Okay, so example 1, solve negative x squared plus y equals 4, x squared plus y squared equals 16. That system of nonlinear equations. What they're going to do in this book is most of the nonlinear equations are going to be quadratics, second degree polynomials. They're going to be the conic sections that we've already seen. There are a few that are rational expressions, which the ones that give you hyperbolas, which is another type of conic section. So I guess you could say they're all conic sections. And they might have a line together with a conic section as well, for some examples. So solution. So I'm going to add the two equations to eliminate the x squared terms, because one has a minus x squared and one has a positive x squared. So if I just add both equations, the x squares cancel out, and all I have left is y's. I didn't do it with the y's because one's a y and one's a y squared, so it wouldn't work. So I added the two, x squared plus minus x squared plus x squared is 0, y plus y squared is y squared plus y, and 4 plus 16 is 20. I'm going to have to move the 20 to the left side. I get minus 20 equals 0. Don't leave off the equals 0. And then I just did this quick factoring thing. You can use the AC method if you prefer. I use this method. So I'm subtracting the products of these two. So subtract the products of 1 times 4 and 1 times 5. So it's 5 minus 4 is 1. So I want the 4 to be minus and the 5 to be positive. There we go. So that was an easy one to factor. So then y is either negative 5 or y is 4. Don't get this confused and think that one of those is x. Neither one of them is x. They each give you an ordered pair of numbers for a solution, or possibly no solution, I suppose. So let's try y equals minus 5 first. Notice I wrote down what I was doing. I would do this on your page as well. So I'm just plugging this into this first equation here. Plugging negative 5 in for y and solving. You can use either one. I just decided to use the second equation. And you get x squared plus 25 equals 16, which gives you x squared equals negative 9, and that gives you x equals plus and minus square root of negative 9, which is plus and minus 3i. It does have to be simplified like that, plus and minus 3i. The y equals 4 in the same equation gives me x squared plus 4 squared equals 16, which becomes x squared plus 16 equals 16, or x squared equals 0, which means x equals 0. So I only got one answer from x equals 4, from y equals 4. So I would write those out as coordinates. 3i, comma, this is 3i, comma, negative 5, and then the negative 3i, comma, the negative 5, and the 0, comma, the 4. And then check each one. You have to check each of these points in both equations, both of the original equations here. So I did the 3i one first. I have the opposite of the quantity 3i squared minus 5x. Minus 5 equals the opposite of negative 9 minus 5 equals 9 minus 5 equals 4, which is what I was supposed to get on the first one. Then I try it in the second one, same point, 3i and minus 5. 3i, the quantity squared, plus negative 5, the quantity squared, equals negative 9 plus 25, which is 16, which checks out. It's supposed to be 16. Now if I put in the one with the negative 3i and negative 5, since you're always squaring the x value, it doesn't make any difference. So I know that one will work as well. So I just made a note of that. It's similar, check. And then try the 0, 4 in both equations. That's the first equation. The opposite of 0 squared plus 4 is 4. And then 0 squared plus 4 squared equals 16. So those check. And just to show you what it looks like, I drew the graph. So x squared plus y squared equals 16 is a circle with the center at the origin and radius 4. Hopefully you know that by now. And then the other one is a parabola, the negative x squared plus y equals 4. I solve that for y. I get y equals x squared plus 4, which is just this parabola that's been shifted from the origin and it's been shifted up 4. So its vertex is at 0, 4. And that also happens to be where one of the solutions. Notice only one solution shows because the other two solutions are outside of the plane somewhere. So that's the real solution, 0, 4. They usually ask for all the solutions, but if they just ask for the real solution, then you would just give 0, 4. In real applications, you just have to go by what the application is. Sometimes it's obvious that you need real numbers, and other times you can use the complex ones.